Alright, so today we're going to take a look at this, the third installment of simplifying trig functions. And what we're going to do, just like before, we're going to write the Pythagorean identities up at the top. Alright, now from here, we have three different problems, and we'll just work through these. In this first example, we don't have common denominators, so I can't add or subtract those. So there's really not much else we can do because nothing's being squared, so we can't use the Pythagorean identities. So what I'm going to do is I'm going to multiply the right side by 1 minus cosine x over 1 minus cosine x, and the left side by 1 plus cosine x over 1 plus cosine x. Alright, so what I've done is, in my attempt to get common denominators, I multiplied the left side by 1 plus cosine x over 1 plus cosine x. Remember, if you divide those, it's just 1 because it's the same thing. So on the other side, the denominator was missing a 1 minus cosine x, so I multiplied by 1 minus cosine x over 1 minus cosine x. And now, our common denominator is 1 plus cosine x, 1 minus cosine x. Right? And on the top, if I distribute these through, I'm going to have sine x plus sine x cosine x. And on the other side, I'm going to get plus a sine x minus a sine x cosine x. Alright? And from here, you can see that actually this right here, sine x cosine x and negative sine x cosine x, they're going to be 0. If you add those, sine x minus cosine x, you're going to get 0. So on the top, if I simplify this, I'm going to have a sine x plus a sine x. And on the bottom, if we FOIL this or distribute, 1 times 1 is 1, and a negative cosine and a positive cosine are going to cancel out. They're going to subtract and be 0, and then a positive times a negative is a negative cosine squared x. So from here, if I rewrite this again, on the top I have 2 sine x's, so I can rewrite that as 2 sine x. And on the bottom, 1 minus cosine squared x, we have a 1 and a something squared. Let's look to our Pythagorean identities. If I take this cosine squared x and move it to the other side, I have 1 minus cosine squared x, so I can rewrite the denominator as just sine squared x. Alright, and now this is, if I have 2 sine squared x's on the bottom and 1 on the top, this will reduce one of these, so I'll be left with just 2 over sine x, which is 2 times cosecant x. Alright, let's take a look at the second example here. Whenever you can clean things up, clean them up. Right off the bat, 1 plus tangent squared beta is the same thing as just secant squared beta. So I'm going to rewrite this as 1 minus tangent squared beta over secant squared beta. And I'm going to add this 1, and since I'm going to get common denominators, I'm going to change the 1 into secant squared beta over secant squared beta. Keep in mind, anything divided by itself is just 1, so I'm just rewriting the 1. Now I have common denominators, so I can rewrite this as 1 minus tangent squared beta plus secant squared beta all over secant squared beta. Now, just keep in mind, you can't cancel these out because of the addition there. Alright, let's look up to our Pythagorean identities. Can I maybe write 1 plus secant squared? See, I can't do that because that would have to move over. What I could do is I could rewrite secant squared beta as 1 plus tangent squared beta. So I'm going to take 1 minus tangent squared beta. I'm going to rewrite the secant squared beta as 1 plus tangent squared beta. Keep in mind that's over secant squared beta. And what's going to happen is this tangent and this tangent are going to add up to 0. A negative plus a positive is 0. So now I have a, this is a plus in here, I have a 1 and a 1, so 1 plus 1 is 2. These are gone. I have 2 over secant squared beta, which is the same thing as 2 times cosine squared beta. Alright, in this third example, what I'm going to do here, I have a tangent squared and a cosecant squared plus cotangent squared x plus 1. If you look here, cotangent squared x plus 1, it's the same thing as cosecant squared. And if I rewrite this as cosecant squared, I'll actually have a cosecant squared in both terms, and I can factor that out. So let's rewrite that. Tangent squared x times cosecant squared x. I'm rewriting this part as plus a cosecant squared x. Right? And on the bottom, I'm just going to rewrite that for now. Secant squared x plus tangent squared x times secant squared x. Alright, now on the top, I have two different terms, this guy and then the one on the right, and I have a cosecant squared in both of them. So let's factor that out. A cosecant squared x factors out. If I factor that out of here, I'm left with just a tangent squared x, and if I factor a cosecant squared x out of a cosecant squared x, I'm left with just a plus 1. Alright, they don't go away. It turns into a plus 1. On the bottom there, I can also do some factoring. I have secant squared x in both terms, so let's factor that out. Let's see where it gets us. If I factor a secant out of a secant squared out of a secant squared, I'm left with just a 1. If I factor it out of here, I'm left with just a plus tangent squared. Alright, and now hopefully you can see where this is going. These two terms, this guy and this guy, are the exact same. They will reduce to 1, and we'll be left with cosecant squared x over secant squared x. We could simplify this even further. Let's rewrite this as cosecant squared x times the reciprocal of secant squared, which is cosine squared. Alright, and cosecant squared, we can rewrite that as 1 over sine squared. So that's 1 over sine squared times cosine squared over 1, which is cosine over sine is cotangent squared x.